Greetings, friend. I will help you understand grouped alternate inference chains, also known as grouped AICs, including all the different types, how to find them, and how to make eliminations using them. I researched dozens of puzzles and web pages to bring this strategy to life for you, and it's the only tutorial on YouTube that covers this topic. You must watch the entire video to truly understand grouped AICs, because I bring out important distinctions in each of the 5 examples. A few guidelines before we start solving. First, this is an extreme Sudoku strategy. It builds upon the concepts of alternate inference chains, types 1 and 2, and locked candidates. Check out my AIC tutorials to get a refresher. Second, I am using Hodoku for this tutorial to show all the candidates and do the coloring, but Hodoku does not allow me to directly share puzzle links. So you can practice using the Sudoku pad links below in the description, or watch my Hodoku tutorial to build these puzzles yourself. And third, all these puzzles are extremely tough and require multiple advanced strategies to solve, in addition to the grouped AICs. Check out video links for some of these puzzles in the description below, and also you have puzzle links there. And with that, it's solving time. For our first example, this is Bubbler by the T-Rex. Mark Goodliff solved it. He used a little bit different strategy than a grouped alternate inference chain, but I'm going to show you that chain here. And so we're going to do a little bit of coloring. And so the idea with an alternate inference chain, you're going with strong and weak links. You know, if something is a strong link, that means if one of the candidates is false, the others has to be true. So usually you do that with a conjugate pair. And so within this cell right here, I'm going to color this one. You know, this has a strong link with the 3, right? That's false. That's going to be true. And then the other bit is a weak link. And so you're going to alternate between those. A weak link means that this is true. This is a 3. Then there can be no other 3s across row 1 there. All right. And then strong links can act as surrogate weak links. So what we're doing a little different here is what I'm about to show you with this next bit. All right, you're starting with this 1 in the orange, and you go into this 3. And now we're going to come over here, and we're going to use both these 3s as a group. And what you can do, and what a grouped alternate inference chain is an alternate inference chain that uses groups of locked candidates. Okay, and so what you have to imagine is that these 2 3s act as one, like you only have 1 3 right there. It works as long as you have a locked candidate, which means the 3s are in 2 houses. They're within the block and they're within the row. It doesn't matter if you have another 3 down here. In fact, most of the time you're going to be switching between, and you're going to treat this as an additional candidate. And that's what we're going to do right here. So we're going to flip over, and we're going to go from these 3s to this 3 right here. So there's a weak link here, a strong link to this 3. And now you're going to go to a weak link within the cell. There's multiple candidates, so it's a weak link to this 2. And now these 2s are going to act as another group. And so they're going to be a group strong link. Okay? And since they're in the column and the block, we can do that. All right? And so you have to imagine, again, like this is 1 candidate, this group, and this is 1 candidate. Just like this 3 is 1 candidate, and this group's 1 candidate. And that's how we can make these strong and weak links work. It's now coming down here. We're going to alternate with the 2 with this 2. So this is a weak link. It's okay to have an extra 2 there. Strong link with that 1. Okay. Come across here, weak link to this 1. And then there's only 2 1s in block 2. So we're going to do a strong link down to this 1 right there. Okay. So this is our alternate inference chain type 1, grouped AIC type 1. And so this is how it works, right? We start right here in this cell. And so you have 1, strong link to the 3, weak to this group 3s, strong to this 3, weak to the 2, strong to the group 2s, weak to this 2, strong to this 1 because it's within the cell, weak to this 1, strong to that 1 because there's only 2 1s in the block. And so you start with a strong link with this 1, and you end with a strong link right here. Whenever you have that situation, you can eliminate any cell that sees the beginning and the end of this chain. because what we're saying is this is a 1. If it's not a 1, this cell here has to be a 1. So any cell that sees both, you can eliminate. And so your elimination, and I'm going to put this in color, is going to be this cell right here, and you're actually going to do a little cannibalizing. You're going to eliminate this cell, this 1 right there, because this 1 and this 1 both see these two 1s. And once you eliminate this 1, you can actually solve this cell for a 5. And it's a critical step in this puzzle, the way he set up this grouped alternate inference chain. You still need another advanced strategy later on, so you want to check out that video. You can see how I solved the rest of that puzzle. But the key thing here is to show that these groups now act as like a single candidate. So this is an alternate inference chain type 1. One more distinction here. This example starts pretty much at the beginning of the puzzle. We only did some minor eliminations prior to getting this step. All the other examples you're going to see, you're well into the puzzle. You had to do some extreme strategies before you get to the spot where the grouped AIC is in place. I just want you to be aware of that if you try to solve these on your own. Let's move on to see how a continuous loop works in our next example. All right, for our next example, we're going to do a continuous loop, which is just like an alternate inference chain type 1 that repeats upon itself. We're starting right here with these 8s, and I'll start with the purple this time. It shouldn't matter. Okay, there's only 2 8s across row 4, and so I can alternate with this 8 right here, get a wink, and now what we're going to use as our group is actually these 2 cells. Okay, you have an 8 here, it's locked candidate within the block, within the column, and it's okay, they're not pointing pairs, it's okay that there's other 8s here. And it's separate from this 8 right there. So as long as you make 2 groups of 8s, it's just like having 2 separate cells with a strong link, all right? This is one group, and then this 8 is by itself. And so you're gonna have another link to this 8 here. Then we're gonna cut straight across to these 3 8s. These 3 8s right there. And then you're going to have these 8s linked to this 8 right here, and then we're going to have another weak link back to the 8. So the way this works is you have a strong link to this 8, a weak link to this 8, right? If this is true, then these would be false. Then this has a strong link to this 8 because either one of these is true or that's true. Weak link to this 8 over here because we have additional 8s. Strong to this 8 because it's the only, besides this group, it's the only link that matters. And then weak to this 8. So strong, weak, strong, weak, strong, weak, strong. It is a continuous loop. Now, what's interesting about this kill zone, and it's all the candidates that we can eliminate, is we can eliminate this cell, this cell. You can actually eliminate this cell right here when we cut back across, okay? Because this is part of the group. Strong here, weak here, you can eliminate any additional 8. So you can eliminate that 8, it gets in the crossfire. And then you go down here, and we come up, weak link here. We can actually eliminate this 8 as well. It gets stuck in the crossfire between the orange and the purple. You're looking to eliminate between the orange and the purple. And then this cell, additional cell at the top, we can eliminate too, because it can never be true. Now you're like, okay, what happens if one of these red cells was true? Well, let's figure that out. Let's say you made this cell an 8. You make this an 8, then none of these cells can be an 8. That can't be an 8. You'd have an 8 right here. You have an 8 here. You'd have an 8 right there. And so you eliminate all the 8s in block 7 because there'd be no 8s here. There'd be no 8 there. So we know that this would break the puzzle if this cell was an 8. Hopefully you can see that. This is an 8. That can't be an 8. This would be an 8. And then all of these other cells would not be an 8. And then because that was an 8, this can't be either. So that's how it works. So we can eliminate all those red 8s. They cannot be part of it. And I wanted to show you this continuous loop to also show you how you can kind of cannibalize and cut through some of those members of that group. If you see value in what I'm showing you here, please consider joining the Smarty Party. I create puzzle packs with much easier strategies than this, but also have exclusive content to help increase your joy of Sudoku. Click on the description below and help invest in the future of Smart Hobbies. So I just covered alternate inference chain type 1 and the continuous loop. Now we're going to move on to discontinuous loops using the alternate inference chain type 2 rules. Okay, for my third example, this is Donut by Shy, and we're a little beyond the beginning of the puzzle. If you remember, I did this with a collaboration with Meme Rister, and it contains an autogon, a tri-value autogon using these cells here. And the big elimination was to eliminate a 9 from down there. We're going past that. There's a ton of grouped alternate inference chains in this puzzle. Shy made it ridiculously hard. We're going to cover a couple of those here with my next two examples. But first, we want to talk about alternate inference chain type 2. I'll remind you of what those are as we work here. So we're going to get our colors going here for our candidate. Okay, we're going to start with this 9 right here. All right, it has a strong link to this 9 because it's the only other 9 in row 1. Okay, and then we're going to use a weak link down to this 9 here. And then we're going to do a strong link to this 9 because there's no other 9s in row 8. Also want to continue down this way. So there's a weak link here. Strong link to this 9. A weak link to this 7. A strong link. Now the group is going to be these two 7s right here. They're a grouped AIC. Okay. And then you got a weak link to this 7. And a strong link to that 4. Okay. And so this is interesting. AIC type 2. We're actually going to start here with this cell. So this 4, you got a strong link to the 7, weak to this group of 7s. And since this is like a grouped AIC, strong link to this 7, because there's no other 7s. There's this group and that as a conjugate pair. Weak to this 9, strong to this 9, weak to this 9, strong to this 9, weak to this 9, strong to this 9. So we start with a strong link in the 4, and in a strong link to the 9. So alternate inference chain type 2, if you remember, you start in with a strong link in the same house, but you have two different candidates. And what it means is you can eliminate the start cell, the start candidate, a 4, from the end of the chain, and you can eliminate the end candidate, the 9, from the start of the chain. The reason being is what we've proven is that this cell is either a 4. If it's not a 4, then this cell has to be a 9. So this can never be a 4, right? Because if that was a 4, this can't be a 4. And if it's not a 4, that has to be a 9. That's how the alternate inference chain type 2 works. Other thing to keep in mind here is you notice there's an additional 7 right there. So we're able to make this as a grouping. We're able to make this have a weak link to it, which is able to do, and then have a strong at 4, and it still works out. I wanted to point that out, that this alternate inference chain type 2 works really well. And of course, if you put a 4 right here, you're going to have a lot of problems, right? You put a 4 here, then this is your 9. That can't be a 9. This would end up being 9. That can't be a 9. This is a 9. And then one of those would be a 7, and then you couldn't put a 7 here or a 4 because you put a 4 right there. Hopefully you can work that out and see why we can eliminate a 4 from right there. All right, so that's alternate inference chain type 2. Now we're going to go to a different spot in the puzzle to talk about a discontinuous loop type 1, which is very closely related to what I just showed you. All right, we've kind of worked back in time a little bit. We're going to show this discontinuous loop. This is actually earlier in the same puzzle. So we're going to start with this 9 up here. And it has a strong link to this 9, right? That first 9, that's not a 9, this has to be a 9. A weak link to this 9 because there's multiple 9s in block 3. Then a strong link to this group of 9s. The 9s are in the column and in the block. So this is one of your grouped chains. Then a weak link to this 9 here. And then this 9 has another weak link to this 9 because there's multiple 9s across the row here, right? And I actually will need to change that to this color here, because then you have the strong link over here to this group of 9s right there. All right, so here's what you got here. You got strong, weak, strong, weak to this 9, weak to this 9 right here, and then this has a strong link with this group AIC, weak, and then strong. So this would be a continuous loop, except you have to have 2 weak links going into and out of this cell right here, right? And what I want to show you is you're not using this 9 right there. That's okay. This 9 is linked up to that 9 in a straight shot, but also has a weak link. And then this is like a conjugate pair with this group 9 right there. And so this can never be a 9. You'll see, whichever way you go. If this is a 9 right here, then that can't be a 9. One of these would be a 9. This could not be a 9. And then without a 9 right here, one of those would be a 9. So you don't have a 9 in this spot, right? If this is not a 9, that's a 9. Those can't be a 9, and then this cell would be a 9. So either way, whether this is a 9 or not, you can never have a 9 right there. So that's why you have weak links going in both ways. Something has to be true on either end of that weak link. So we can eliminate a 9 in this cell. So this is a discontinuous loop type 1 where you have 2 weak links in a row. So we can eliminate that 9 and move on with the puzzle. So now let's move on to our last example, very important one. We're going to show you what happens if you can get 2 strong links together. Okay, our last example, I pulled this off of Sudoku Wiki page. It's the AIC with groups. I got links to those references below. I'm going to bring this to life so that if you're looking at the diagram, you're not really sure how to do this, I will show it to you. Also keep in mind that the diagram is not necessarily the beginning of the puzzle. There's some additional candidates that you remove because of some easier strategies that have been applied. I'm just showing you exactly the way the strategy is and the way the diagram is on the wiki and where we go next with this grouped AIC. So we're going to start up here in this cell with this 8, and we'll just go with, so this 8 has a strong link to this 4, right? So strong link to that 4, and then you come down and our grouped AIC is right here, a weak link to these 2 4s. Okay, so those, again, it's okay because they act as a lock candidates. They're in the column and they are in the block. All right, and then these weak, they have a strong link to this 4 because it's the only other 4 in block 6. And then it has a weak link to this 2. It technically is a strong link, but we're using it as a surrogate weak link so we can alternate the inference chain. Strong link to this 2 because it's the only other 2. Weak link to the 8 right there. And then what you'll notice is you have a strong link to this 8, it's the only other 8. And then we have another strong link to this 8. And then a weak link to that 8 right there. We start back over again. So 8, strong to the 4, weak to this group 4, strong to this 4, weak to the 2, strong to this 2, weak to the 8, strong to this 8, strong link to this 8, because it's the only 2 8s in column 4, weak to this 8, strong to 4. So this would be a nice continuous loop, except for these 2 strong links going into and out of this cell right here. And whenever you have 2 strong links in a row, it's a discontinuous loop. It's called a type 2. And what you know with certainty is that no matter which way you approach this chain, this cell always will have to be an 8, right? Because if this was not an 8 right here, then that'd be a 4. These couldn't be a 4. That'd be a 4. This cannot be a 2. That'd be a 2, knocking out this 8, making this an 8. Okay, cool. This is not a 4. That's an 8, which knocks out this 8. And the only other place in column 4 to put an 8 would be right here. Both situations, this has to be an 8. So what we can do is solve with certainty this cell, 4, and 8. And we use this grouped alternate inference chain right there. Another question you may have that I didn't fully cover is, could you go from one group to another group? The answer is yes, between houses, in houses. If you had like a T shape, so like you had 2 4s here, and then the 4s were up here, you can go between one lock candidate group to another lock candidate group within a house. You could also go, if you had the T shape, the 4s were here, and then you had another group of 4s over here, you can do that as well. It's all possible. There are a couple of examples on the Sudoku Wiki that show that. Get some more practice with alternate inference chains with this next video. Thank you for all the setters that gave me these puzzles to feature on this tutorial, and I want to thank you so much for watching.